What's going on, guys? Let's do this problem right here. The question is asking to evaluate the following telescoping series. We have this telescoping series right here, but this one we can write in a different way too, like sigma n is equal to 1 to infinity ln n plus 2 minus ln n. Because whenever we have natural logarithm, if it's dividing each other, it means it's subtract. If it's multiply, it's mean addition. So we can write the same thing like this one too. So now what we are going to do, we can take a partial sum and find out the pattern. So in this case, let's take four values. Let's say n is approaching 4, like sigma n is equal to 1 to 4, and see what happens, right? So here the thing is we have to pick up a pattern and write it in a generic term. So if I plug 1 for this one, this is going to be ln 3 minus ln 1 plus, if I plug 2 for this one, this is going to be ln 4. So let's put them in the bracket. So this is ln 4 minus ln 2. If I put 3 for this one, this is going to be ln 5 minus ln 3. And if I plug 4 for this one, this is going to be ln 6 minus ln 4, right? So now it's giving a pattern. Now all we have to do is we have to cancel whatever we can cancel and see what is remaining. So here if you look at this one, we have negative ln 3, positive ln 3. We can cancel that one. And also we know that ln 1 is equal to 0, so we can cancel that one too, 0. And ln 4 plus ln 4 minus ln 4, we can cancel that one. And whatever, so we have negative ln 2, ln 5 and ln 6. So let's write this one down, whatever thing that is remaining. Negative ln 2 plus ln 5, and then we have ln 6, right? And what happens if we increase 5, like if we go to 5, we are going to have ln 7 minus ln 5. Then this ln 5 and minus ln 5 cancel, we are going to have 7. So it seems like this negative ln 2 is not going to cancel, so it's going to always remain the same. So let's say if we have sigma n is equal to 1 to k is random number. If it's k, the pattern is going to be ln 2. Ln 2 is not going to cancel anyway, like it's not going to cancel. No matter what value you put, it's not going to cancel. So ln 2 remains the same, but we are going to have k plus, like here we chose 4, so it's going to be k plus 1, ln k plus 1, and then ln k plus 2. So this is the pattern we have. Now all we have to do is take the limit for this one. If I take limit, that's going to give us the answer whether it is diverging or converging. If it's converging, we have to find the convergent value. So here let's take the limit. Limit is going to be limit k approaches infinity. We are going to have ln 2 minus ln 2 minus ln 2 plus ln k plus 1 plus ln k plus 2, right? K plus 2. And then from this one we can say if we plug ln infinity, that's going to be infinity. So this value is infinity. This is also infinity. If you plug infinity for k, that's going to be infinity. So the answer for this one is going to be infinity, because if you add negative ln 2 to infinity, that doesn't change anything, right? So it's going to be infinity. So the answer is going to be infinity. Whenever we don't have a finite value, that's divergent. So this is not a finite value, so this is a divergent series, and that's how we evaluate these kind of problems. I hope you guys find this video helpful. See you next time.